Alrighty guys, so up here on the roof, there's solar panels, weather station, bag of tools, more tools, another rain gauge. So what I ended up doing at this point in time is this right here is a 2 meter antenna, 2 meter 440 actually, for my amateur radios. This here is the Davis anemometer, and then over here I went ahead and I've got the weather station mounted up here. There's two of them. That's the Oregon Scientific and then the La Crosse. Got those up there, and on the pole on the mount, Latham Sire helping out. He's gonna wave. Woohoo!
I predict sunshine.
Sunshine, yeah, a rare thing here in Washington. So basically, this is the mount that used to hold the amateur radio antenna. And then we got the other stuff in there. Okay, so next I'm going to go ahead and be mounting the Davis station up there and the anemometer. I'm probably going to do the anemometer first because that one I have to be a little bit more specific and make sure I've got that one pointing north, and if I need the extra space to move it around, I can do so. And I'll show you that in just a minute when I get it up. Alrighty guys, so we've got the Davis anemometer and vane up there now. I'm pretty sure I'm going to either raise that one up higher so it's higher than the Oregon Scientific, because right now if we get some southern wind, which really doesn't happen too often, the Oregon Scientific may block the anemometer on this one. Getting ready to hang the Davis station right there about where that black tape is. But one thing I wanted to share with you guys first is the original rain cone that came with this was not a cone like this one. It was, I mean, much larger, but it was actually shaped like this. So Davis actually allows you to upgrade the cone so it's not just like a cup like this. And this is much more aerodynamic. It also comes with a better screen in the bottom. Hopefully you can see that. So that screen unscrews and you can empty out the gunk. They both had the bird spikes, so we didn't really have to worry about that. I think some of the much older models did not have the bird spikes. But this is a new addition, and surprisingly, there's only 30 bucks to get the new piece. So I was expecting it to be a lot more, and it wasn't too bad. Okay, guys, so we've got the large portion of it hanging up there. I've got the cable for the anemometer just kind of resting there still. Hopefully, you can see that. What I need to do now is I'm going to kind of point you in towards the top right here. This is the level. We got to go ahead and level the weather station. Once we get the weather station leveled, from there we can dial in the rain gauge as well as the UV and solar radiation sensors. So each of those have their own screws to tighten it down so you can get those perfectly level and go from there. Okay guys, so something else I wanted to share with you really quick is how I guy line out my weather station. So basically what this is right here is 350 pound static, which means it's non-stretch fishing line. And what I'm going to do is, because the current house does not have gutter screws, it has gutter nails, I'm going to pull out a gutter nail and replace it with a gutter screw. And then what I do is I use the line and the turnbuckles to guy it out. And I always, when I pitch my weather station, I'll actually have it cant just a little bit to one side. And that way when I pull it back even, it has tension on one side, and I'll probably even pull it just a tiny bit the other way, and then the last turnbuckle on the back, I'll pull it back the other way. That way it has really good tension, and when the wind gets blowing, it doesn't wobble around up there. That's one thing I've noticed that people have an issue with when they're setting up their stations. They don't get them guyed out correctly, or they use line that is stretchy and it will still waver in the wind. Alrighty guys, so first thing in the morning here, quick view of Mount Rainier way off in the distance over there. So partly cloudy skies, decent cloud that way towards Mount Rainier, but we got the weather station set up last night. It got dark, so I couldn't continue to film. Everything is ready to go, and we're gathering data. The solar panels are working, the weather vanes and anemometers working. Alrighty guys, so here at the weather stations anyways, trying to get a view where we don't have the light glare. The Oregon Scientific and the Davis should actually read pretty close together as far as temperature goes, since the sensors are in the same place. We're going to have a little bit of a discrepancy with this one because it is actually in a different location. Actually, it's reading offline right now, interesting. I'll have to investigate that. Over here with the Davis unit anyways, 44 degrees also. Barometer is at 30.11. Barometer on the La Crosse, 30.11. Humidity on the Oregon Scientific at 98% and 95% over here on the Davis. With the Davis, since we have the UV and solar radiation, so we have solar at 105, UV is still at 0, 96% on humidity, just up a tad. So no wind anyways, but let's go ahead and take a look at how solar radiation looks in comparison to what the MidNite Solar is taking in. Alrighty guys, so 9 o'clock in the morning here anyways. Solar radiation is at 148 watts per meter squared, and that's the information there in the lower right on the weather station. And up here on the MidNite Solar, says we've got 54.4 volts, and we're taking in a little minuscule 25 watts, charging at 2 amps. Since the inverter is on, the battery voltage is actually reading a bit lower. But we've got 12.5 volts. Batteries are pretty full. I didn't have the solar running last night. I had to unplug it so I could use some other stuff and forgot to plug it back in.